first step in the manufacturing process really begins in incoming receiving. It's in this particular station where we verify that the parts we receive from our vendors are in fact exactly what they're supposed to be. If we can't give perfect parts to the production floor, they can't build beacons that are going to work the first time every time. In order to equip our incoming inspection team with the latest in technology, we have invested in equipment that allows them to check tolerances electronically with our Smart Scope, for example, or with the XMET X-ray analyzer. We're able to determine the exact material content of components. We've invested in this technology so that we can build products that we know are going to work when they're required to. By investing in the latest in technology relative to surface mount technology, that allows us to keep the production here in the U.S. and maintain control of the manufacturing process. And process control is the key to quality control and quality assurance. In the SMT room, we place the paste solder on the boards with a stainless steel screen that gets vacuumed down to the PCBs, and then we go to a quality assurance step, and we have an optical scanner that looks at the paste and makes sure that it's the right volume, the right placement, the right size. And then we run them through an oven that allows us to use a lead-free solder. We don't have to invest in lead-free, but that's something that we just feel it's the right thing to do. Once again, as we come out of the SMT machine, we go into an optical inspection station that checks the part, the soldered part, against a blueprint, makes sure that all the right components are on the board, on every board, and that they're in the right place. And then there's some of the components that are extremely small, or the solder points, the ball grid array is on the back side of the, or buried in a way so that we can't visually inspect it. From ACR's point of view, we have to be able to ensure that those solder points are all perfect. So we have a PCB X-ray analyzer. You could say we X-ray our solder balls because we have to. We can look through the part to the solder point on the backside and ensure that it's going to really basically continue to work, not just the day it's manufactured, but over a lifetime of drops, over a lifetime of vibration and temperature changes and thermal shock. The boards have been tested, tuned, and approved by quality, and the next step is we conformally coat them in a layer of silicone, which basically we spray this thing with silicone and we cure it in an oven. The value of conformal coating is that it allows us to protect the board from electrostatic discharge. If for some reason the case should ever be compromised, it protects the boards from water intrusion and gives it a better chance of working in a crisis mode. And it also gives us the opportunity to inspect that. It preserves the board if it ever comes back to us. It allows us to inspect the board and make these products better over time. No one makes us conformally coat these boards. It's not a government mandate. It's something we do because we believe it's the right thing to do. Here we are at the final phase of assembly, and we take the fully assembled and sealed board, and before we put it into the case, we run it through a 45-minute fully operational burn-in test. It's kind of like a test drive. We power this board up, we hook it up to an antenna load, and we run it just like it would in real life. Once that beacon has passed that final burn-in test, we assemble it into the final case. We do some other mechanical tests, we do some operational tests, and it goes out to be packed. But the final stage, really, the queen moment of the entire process, happens in this final assembly room. There's one more step in the process. Essentially, the process is over and we've shipped the product and it's gone out the door. But it really isn't over yet. There's one more phase in this science of survival, and that is pulling random samples from production lots, taking them back to the test lab and testing them against the original standards to make sure that every unit that we're building in production is as good as, and most generally it's better than, the units that we sent to the test lab way back in the beginning of the design and the evaluation process. No one tells us that we have to do that. No one makes us do that. We do it because it's the right thing to do, We do it because we build quality products knowing they are used to save lives.